Alright, so on your review, the first one says that 1 correctly found a table of values for each equation in a system of equations as shown below. What is the value of y in the solution? Come in. Come in. It doesn't lock, it's broken.
I'm just here to watch.
Okay. Alright, so remember that they're not asking you here to actually create the table. They already have it. They just want to know what the solution is. So remember, if a solution is where the two equations are equal, you want to look at the table and see where the two values are equal. Both values. So if you look at 0 here, it gives you 9. Does 0 give you 9 here? No, so that one's out. If you look at 1 here, it gives you 7. There is no 1 here, so can 1 be where they're equal? Okay, if you look at 2 here, it gives you 5. 2 gives you 5 here. Are those equal? So this is the solution. Which one of those numbers is the y value? 5. So 5 is the answer. Had it asked for the x value, what would we have said the answer was? 2. So just remember the x is first and then y. The table said x and y, but they don't always say x and y. Okay? So that was the first one. Turn to your next slide. Alright, this one says that the school band collected $2,892 for 480 tickets sold at their spring concert. Adult tickets were $8 and student tickets were $5. How many children's tickets were sold, or student tickets, but not the adult? So remember, we've been doing systems of equations and writing our own. So if 480 tickets were sold, that's the total for student tickets and for adult tickets, right? Remember, and is plus in math. So we got 480 tickets. How much were student tickets? $5. So if I put the 5 with the S, how much were the adult tickets? $8. So I can put the 8 with the A, and we made $2,892. So this is basically your system. Alright, so when you have a system, make sure you're solving for the right one. Children's, that's students. Children's, students, same thing. Not the adults. So you can choose to solve this however way you want. We can put it in the calculator and take the shortcut. We can graph it. We can try to create tables. We can do substitution, elimination. I think since it's already in standard form, elimination is probably the easiest. Remember, you have to have one of the variables match. So here I have a 1 and a 5. Here I have a 1 and an 8. So neither match, but I can take this top equation and multiply it by something to make it match. Okay? So if I want to solve for children's tickets, I don't want to cancel the S. I want to solve for it. So let's cancel the adult tickets instead. There's only 1 here. If I multiply it by 8, it'll be the same as this one, right? If I make it a negative 8, I will be able to add my signs and not even worry about mixing them up. So I'm going to distribute. 8 times, or negative 8 times S is negative 8S. Negative 8 times A is negative 8A. You'll help me out with the math. What's negative 8 times 480? Negative 8 times 480. This number? Is that what you got? Okay. So when we are going to combine to eliminate, because remember this method is called elimination, what's 5 minus 8? Negative 3. And then 8 minus 8 cancels, that's why we did it. So what's the 2,892 minus 3,840? Right? Okay, what do we do for the last step? Yeah, what do we do for the last step? Yes, perfect. We divide by the -3. So our student tickets are how much? Or how many were sold, I should say. We know how much they were. $316. So that's how many student tickets were sold. Had we accidentally solved for A instead, we would have just had to finish the problem. Remember, normally once we have one answer, we plug it back in to get the other. So had we not been careful and chose to eliminate the adult price of the tickets or the number of tickets, and we accidentally solved and we had what A equals, we would just plug it back in up here and easily get the student tickets. But this is how many student tickets. All right. Had they asked for adult tickets, we could have just made sure that we multiplied by the -5 in order to cancel the students instead. So just be aware that there's not only one process. To be honest, you didn't even have to do elimination. You could have done substitution or graphing or, put it into the calculator. Now, turn to your next slide. Alright, so a system of equations is shown below. We've got 3x plus 2y equals 10, and y equals x plus 1, and it says to solve. Does it say how we solve? No. So we've learned several methods, and when you're actually taking your test, you can pick. But since this one is in standard form and this one isn't, if I did elimination, I'd have to change this one. If I did graphing, I'd have to change this one. But substitution lets me go ahead and plug what y equals, which is this, right into that. So it's a little faster in this one. So that comes with experience. You get to choose whatever method you want when it doesn't say. And so with experience, you'll get used to which one's faster given certain circumstances. So if I'm going to plug this into this equation, I've got 3x plus 2y, but what am I going to put for y? What's y equal? Yeah, x plus 1. So we're doing substitution here. So we got to get rid of our parentheses, so I'm just going to leave this 3x here. What's 2 times x? Yeah. And then 2 times 1? 2. So we got to combine our like terms. These two right here are both x's, so they're going to combine. How do I move this plus 2 over here with this 10? Subtract it. Perfect. So those will cancel. What's 3x plus 2x? 5x. And what is 10 minus 2? 8. Okay. What's next? Yep, we divide by 5. So in this particular case, x doesn't give us a whole number, does it? You can either leave it 8 over 5 or you can make it a decimal. It's fine either way. If we make it a decimal, it's 1.6. It's not like a rounded version. It's exactly 1.6. So either answer is fine. Okay. When we go plugging it back in, remember we substituted this one. Alright. So into this one. But now we can plug this one back here because it's an easier one, isn't it? So if I want y, I can just say y equals x plus 1, but what are we going to use for x? Yeah, 1.6 plus 1. So what is 1.6 plus 1? 2.6. So if I put it as a point, x is 1.6 and y is 2.6. You could have left it as a fraction if you wanted to. Okay, questions on that one? Do y'all remember the method of putting it in the calculator? Do y'all want me to show you how we could have got that in the calculator too? Yeah, let me grab one of those calculators. I might have to refresh my memory just because it was new for me too this year when I saw the shortcut that you could do. For those at home, this shortcut only works with this calculator, but I did post some videos of how you could do it in other calculators. All right, so remember, we go to our calculator screen. Ooh, focus. We go to our calculator screen, which is this button. We hit menu, and then algebra is 3, and then solve system of linear equations, which is 2. We want 2 variables, or 2 equations with the 2 variables being x and y, which is pretty much what it usually says. Then we type in the first equation on the first line, which is 3x plus 2y equals 10. Then tab takes us to the second equation, and then we type in y equals x plus 1, and then we hit enter. And see how it says 8 over 5, 13 over 5? Well, remember, the 1.6 was 8 over 5, wasn't it? If I added 1 to that, I'm adding 5 over 5 to it. 2.6 is 13 over 5. Just so you see, 13 over 5, 13 over 5 is 2.6. So it did give us the same answer. It just put it in a fraction. Also remember right here, you can tell your calculator to make a fraction a decimal. You hit menu, number, which is the 2, and then convert to decimal. See? Isn't that the same exact thing we got? So for those of us that have the Inspire here in the classroom, this is a good way. If you're at home and you don't have the Inspire, like I said, there were ways to do it with the TI-84s or with Desmos, and I put the videos up for that. So it's just a shortcut. So turn to the next slide. This one says graph the solution set to the following system. This is like what we've been doing this week. Okay? So remember, when graphing, you have to have the y alone. Neither one of these do. So we have to rearrange them. So this first one here, I've got 2x is greater than or equal to y plus 2. So if I want y alone, I can minus this 2. Okay? But y is usually on the other side, isn't it? Notice, see how the thing is pointing at the y? So if I rewrite it, I want to keep y being pointed at. See when I moved it? This is your b. So at -2. And then your slope, if it's not a fraction, you can put over 1. So up 1, or up 2 over 1. Up 2 over 1. So I'm just putting a bunch of dots on my graph. I can also go down 2, but then I go left 1 so that it keeps going. Okay. Is this going to be a dotted or a solid line? Solid, because that's got the line under it, right? So here's this line. And notice it's a less than or equal. So should we shade above or below when you see a less than or equal? Just think about the word less. Yeah, less than is going to go down, so it's a below. Okay? So if I want to shade below, that would be on this side of the line. My highlighter's running out, but I didn't mean to cross over right there. Let's see if this highlighter does a little better. Got a bunch of yellow highlighters. I need to get some more pink ones, huh? Alright, so for the other equation, for this one, we got to solve it also. So we got 2x minus 5y is less than or equal to 10. In this case, the y is on the left, so I'm going to leave it. But I got to move the x over to the right side. And that is accomplished by making it negative. Okay. And then when I rewrite this, I'm just putting the x first because, you know, y equals mx plus b is the format we're used to. Here, when I divide by this negative, the most common mistake people make is they forget to flip this. If you multiply or divide by negative, this symbol has to flip around. So it was a less than, it's going to become a greater than. Negative divided by negative is a positive. And then positive divided by negative is negative. 10 over 5 is 2. So we start at negative 2 again. Same place right here, right? But this time we're going up 2 over 5. So up 2 over 5. Up 2 over 5. Or if I want to go down 2, I go left 5. Down 2, left 5. This line is solid too because it's got the or equals. Is that greater than going to be above or below when we shade? See how it's the opposite of this one. So since this one shaded below, this one should shade above. So I shade above this blue line. Toss these. I do think I have another blue one. So I'm going to shade above this blue line. But remember, the solution is where they both are shaded. So in this case, the pink and the blue. So that's here. This area. That was shaded in pink and blue. Now, of course, on the actual test, which they're always multiple choice, you won't have to graph it yourself. What it'll be is they'll have like graphs for you and you pick which one's the right graph. Okay? So that's kind of the difference here. I'm going to pause the video. That way we don't have one video that's super long. And then I'll re-record the video and attach it too.